Hello friends, I welcome you in lecture number 10 on Poisson distribution. In this lecture we will discuss one more problem which was asked in GTU 2020 examination. So first we try to understand what is given. If the probability that an individual suffers a bad reaction from a certain injection is 0.001, find the probability that out of 2000 individuals more than 2 individuals and exactly 3 individuals will suffer a bad reaction. So here we are given the probability that an individual suffers a bad reaction from a certain injection, and there are total 2000 individuals, and out of those total 2000 individuals we have to find the probability of more than 2 individuals and exactly 3 individuals which will suffer from a bad reaction. So first of all we decide that this is the problem of which distribution. So for that first we consider a random variable capital X equal to number of individuals number of individuals which suffer a bad reaction, or number of individuals suffering from a bad reaction from certain injection. Okay, so this is enough number of individuals suffering from a bad reaction, and there are total 2000 individuals. So possible values of small x are 0, 1, 2, 3 up to 2000. So there are 2000 individuals. We can consider small n equal to 2000. So there are 2000 individuals. For each individual there are only two possibilities: either individual suffers a bad reaction or he or she does not suffer a bad reaction. So we can observe that this is the problem of binomial distribution. If we consider success as an individual suffers a bad reaction, then we are given the probability of success. It is given that the probability that an individual suffers a bad reaction from a certain injection is 0.001. So here the probability of success, that is probability of this event, an individual suffers a bad reaction, is given as P equal to 0.001, and there are no dependency of one individual on remaining individual for a bad reaction. Okay, so suffering a bad reaction is independent for individual to individual. So we can say that for this experiment trials are independent. So this is the problem of binomial probability distribution. All the four conditions of binomial distribution are satisfied. But here number of individuals are 2000, which is very large number, and probability of success is 0.001, which is very small. So as we know, if number of trials are very large and probability of success is very small, we can approximate binomial distribution by using Poisson distribution. And as we have discussed in lecture number 3 on Poisson distribution, that if number of trials is greater than or equal to 20 and probability of success is less than or equal to 0.05, then it is better, binomial distribution and Poisson distribution are approximately equal. That is, if n is greater than or equal to 20 and probability of success is 0. less than or equal to 0.05, then we can approximate binomial random variable by Poisson random variable, that is probability distribution function, probability mass function of binomial random variable tends to probability mass function of Poisson random variable if n is very large and probability of success is very small. So here, because number of individuals or number of trials are very large and probability of success is very small, we will not use binomial probability mass function here. Instead of that, we will approximate binomial distribution using Poisson distribution with mean of Poisson random variable as lambda equal to n into p, that is number of individuals into probability of success. So this is the problem of Poisson approximation to the binomial distribution, and this is acceptable rule of thumb. We will remember this rule, that in which case Poisson approximation is good to binomial distribution. So if n is greater than or equal to 20 and probability of success is less than or equal to 0.05, then it is good approximation, that is Poisson distribution is good approximation to binomial distribution. So here we consider Poisson distribution to find out solution of given problem. So we can write that here number of individuals n equal to 2000 is large and probability of success is very small. Here also we can write this is very large and probability of success is very small. Therefore we use Poisson approximation, or we use Poisson probability distribution to approximate binomial distribution. So for that, lambda equal to n into p, that is 2000 into probability of success, which is 0.001. So this is nothing but 2. So therefore the probability mass function of random variable x is probability that capital X equal to small x equal to, we are using probability mass function of Poisson random variable. Okay, here our random variable x is binomial random variable, but because number of individuals is very large and probability of success is very small, so we are approximating binomial random variable with Poisson random variable. So we are using probability mass function of Poisson random variable with lambda equal to n into p. Here x can take values starting from 0, 1 to 3 and so on. So therefore probability that capital X equal to small x equal to e raised to minus 2 raised to x over x factorial. X can take the values 0, 1, 2, 3 and so on. So in first part we are asked to find out probability of more than 2 individuals, that is value of small x is greater than 2. Probability that more than 2 individuals suffers a bad reaction. So this is the probability of x individuals who suffer a bad reaction. So here our value of small x is more than 2, that is here capital X is strictly greater than 2, because number of individuals who suffers a bad reaction is more than 2. So we write capital X is greater than 2, and we know that x is less than or equal to 2 and capital X greater than 2 are complementary events. So we can write probability that capital X is greater than 2 as 1 minus probability that capital X is less than or equal to 2. Now this is nothing but sum of probabilities starting from x equal to 0 to x equal to 1 to x equal to 2. So now we can find out these probabilities using that formula of probability mass function. So here we will put x equal to 0, 1 and 2. E raised to minus 2 can be taken common. For x equal to 0 we have 2 raised to 0 over 0 factorial. For x equal to 1 we will have 2 raised to 1 over 1 factorial and 2 raised to 2 over 2 factorial, and we can take e raised to minus 2 common. So we write directly by taking e raised to minus 2 common, and here 2 raised to 0 over 0 factorial, 2 raised to 1 over 1 factorial, 2 raised to 2 over 2 factorial. So 1 minus e raised to minus 2, this is 1 plus 2, and here there will be 4 divided by 2, that is 2. So we have 1 minus, this is 5 times e raised to minus 2, that is nothing but 1 minus 5 divided by e square, and using scientific calculator we obtain this value 0.32332. So this is the probability that more than 2 individuals suffer a bad reaction. Now if we are not going to use scientific calculator, or if we are not interested in doing these calculations, as usual we can use cumulative probability table for Poisson distribution. Okay, so this we can do using cumulative Poisson probability table directly. For that we will consider lambda equal to 2 and small x equal to 2. So we find out this is cumulative Poisson probability table. We are interested in the probability that capital X is less than or equal to 2, and here lambda for this problem is 2. So we search for lambda equal to 2 and small x equal to 2. So if we take intersection of these two, this is row corresponding to x equal to 2, and this is column corresponding to lambda equal to 2. So we find out the point of intersection of this x equal to 2 row and lambda equal to 2 column, and we see that we obtain this value 0.6767. So this probability using table is 0.6767. So we can write here that probability 0.6767, and if we take subtraction we have 0.3233. So using cumulative Poisson probability table we obtain the same value up to 4 decimal places, 0.3233. So if your calculations are very lengthy, you can use cumulative Poisson probability table also. Now we do part 2. So in part 2 we are asked to find the probability that exactly 3 individuals will suffer a bad reaction. That means we have to consider small x equal to 3 here. So probability that exactly 3 individuals will suffer a bad reaction. So this event is equivalent to probability that x equal to 3. So we put small x equal to 3 in that formula. So e raised to minus 2, 2 raised to 3 over 3 factorial. So this is nothing but 8 divided by 3 into 2. Here we can cancel out 2, and we have 4 divided by 3. E raised to minus 2 can be written as e square, 1 over e square. And if we use value of e using scientific calculator, we obtain this is 0.18045. So this is the probability that exactly 3 individuals will suffer a bad reaction. If we wish, we can use table also. For example, suppose we want to find out this same probability using table, then table is given for cumulative Poisson probabilities. So for that we rewrite this probability as probability that capital X is less than or equal to 3 minus probability that capital X is less than or equal to 2. This we have obtained in part 1. It was 0.6767. So that we write directly 0.6767, and this we write from the table. So we have to search for X equal to 3 row, lambda equal to 2 is there, and we consider intersection of X equal to 3 row and lambda equal to 2 column, and we find this value at the point of intersection. We have 0.8571, so that we write here, and if we take subtraction we have 0.1804. So that is same as this value up to 4 decimal places. So in this way we can use Poisson approximation to find out probabilities of binomial distribution. Okay, if you wish, we can do the same problem using binomial probability distribution also for understanding. Suppose we want to do the same problem using binomial distribution, and we can check how the approximation is good. Okay, so we are doing the same problem using binomial distribution. So for that, first we write down the probability mass function of binomial random variable is given by probability that capital X equal to small x equal to NCX p raised to x 1 minus p raised to n minus x. Here x can take the values 0, 1, 2 up to n. Now in our case n is 2000 and p is 0.001. So we write here 2000 Cx, p is 0.001 raised to x. 1 minus 0.001 will be 0.999 raised to 2000 minus x, and possible values of x are 0, 1, 2, 3 up to 2000. Now in part 1 we are asked to find the probability that more than 2 individuals will suffer a bad reaction, that is probability that capital X is greater than 2, that we can rewrite as 1 minus probability that X is less than or equal to 2. So we have to find out sum of these probabilities, capital X equal to 0 plus capital X equal to 1 plus capital X equal to 2. So we will find out value of this right hand side for X equal to 0, 1 and 2. So for X equal to 0 we have 2000 C0 0.001 raised to 0 and 0.999 raised to 2000. Okay, so we are putting small x equal to 0 here. So we have this. Now we put small x equal to 1. So we have 2000 C1 0.001 raised to 1 and 0.999 raised to 2000 minus 1, that is 1999. So we write 2000 C1 0.001 raised to 1, 0.999 raised to 2000 minus 1, that is 1999. Similarly for small x equal to 2 we have 2000 C2 0.001 raised to 2 and 0.999 raised to 2000 minus 2, that is 1998. So using scientific calculator you can check that these values are 0.1352 plus 0.27067 plus 0.27081. Okay, I have calculated using scientific calculator. So this is nothing but 1 minus sum of these three values turns out to be 0.67668, that is 0.32332. So this is the probability that more than two individuals will suffer a bad reaction. Now in second part we are asked to find the probability that capital X equal to 3, that is 3 individuals will suffer a bad reaction. So that we can calculate using this. For small x equal to 3, we have 2000 C 3.001 to the power 3, 0.999 to the power 2000 minus 3, that is 1997. So this is 2000 C 3.001 to the power 3, 0.999 to the power 199C, and using scientific calculator I obtain this as 0.18054. So these two answers we have obtained using binomial distribution, and we compare both the answers to check how approximation is good. So in part 1, using Poisson distribution formula, we obtain this probability capital X is greater than 2 equal to 0.32332. So this we compare with the probability obtained using binomial distribution. So we have obtained the same answer, 0.32332. So we can see how Poisson approximation is good enough to given binomial distribution. Now in second part, probability that capital X equal to 3 using Poisson distribution is 0.18045. This is using Poisson distribution 0.18045, and using binomial distribution we obtain 0.18054. Okay, first we write this probability using Poisson distribution. We obtain 0.18045. 0.18045. This is probability that capital X equal to 3 using Poisson distribution, and using binomial distribution we obtain 0.18054. So we can see both are exactly same up to 3 decimal places, and these probabilities are exactly same. This is 0.32332. Okay, so using Poisson or binomial we can see that these two probabilities are exactly same up to 5 decimal places, and this probability is same up to 3 decimal places. So from this we can have the idea that how good the Poisson approximation is to binomial distribution. So if number of trials are very large, that is n is tending to infinity, and probability of success is very small, then we can use Poisson distribution with mean lambda equal to n into p to approximate binomial distribution. Okay. So this same problem you can do either using Poisson approximation, or you can do the same problem using binomial distribution as per your convenience. But I think if I am using Poisson distribution, then I will have a small number of calculations as compared to binomial distribution. Here you can see calculations are small as compared to this binomial probability distribution. Okay, so that is your choice, which approximation, which distribution you are interested to use. But we will remember this fact that if number of trials are very large and probability of success is very small, then we can approximate binomial distribution by Poisson distribution. And we will remember this rule of thumb, that if number of trials is greater than or equal to 20 and probability of success is less than or equal to 0.05, then we can approximate binomial distribution using Poisson distribution. Now this is not very strict rule. Some authors are using other values also, but we can remember this rule to approximate binomial distribution by Poisson distribution. So this is all about today's lecture. I hope you like it. Thank you very much.